Hello, everybody. My name is Ryan Clark. I'm the founder and CTO of Syntax Bio. So we have invented a cell programming technology that we are using to realize the potential of stem cells for cell replacement therapies. So the concept of this type of cell therapy is to take stem cells, which have the ability to be converted into any cell type, and to take them and to convert them into a tissue-specific cell type, and to take those tissue-specific cells, transplant them into a patient's diseased or damaged tissue. And the idea here is that that transplant will be a single dose that will cure the patient of that ailment. Because stem cells have the ability to be converted into any cell type, this modality has a lot of promise because very, very large indications can be treated if you can make the right cell type. And pharma has been investing in this space for about 20 years now, and there's been a lot of exciting progress where recent clinical trials have shown that, for example, a dose of pancreatic cells can cure a diabetic patient, making it so they don't need an insulin injection ever again, or paralysis can be cured with spinal neurons. So the sector has been growing slowly but surely since the derivation of induced pluripotent stem cells back in 2006. So there are over 100 clinical trials now across many different tissue types and indications. And there is a lot of deal value associated with each of these assets, with close to $500 million in biobucks on average for just a single asset. And pharma has been striking a lot of these deals over the last several years. But what you probably noticed with this graph showing clinical trials over time is that this curve starts to plateau in the recent years. And that is because the manufacturing is a massive challenge. Manufacturing a single batch of cells typically takes 1 month or many months. There is a high risk of variability that can lead to batch failures. And at the end of the day, a dose of cells will cost millions of dollars, essentially making this modality commercially not viable. The reason that the manufacturing is so difficult is because it's analogous to where the punch card era was back in the 1950s, or where the computing era was back in the 1950s, where we were using punch cards. So it works to compute, but it's very slow, it's very manual, and it's hard to QC. So how this works with the current method is that scientists will take their bioreactor growing their stem cells, and they sequentially add different recombinant proteins over a many months procedure. And so if you mess that up, you have to start over. So the iteration cycle time is very, very slow as you're optimizing your protocol. And again, it's very onerous and it is hard to QC. So what we are doing at Syntax is we are bringing this modality into the modern era, analogous to how microprocessors and software are used for computing. And we're doing this through our technology, which is called cellular algorithms or cellgorithms. So cellgorithms are encoded in the language of the cell, which is DNA. And what they specifically encode is a CRISPR system that we invented. And so how the process works is you deliver your cellgorithm just one time to your stem cells, and it runs pre-programmed gene regulations that turn genes on or off in a stepwise manner. And this is automatic, and it's very, very fast. So it's just like pressing run on a computer program, and the lines of code are executed over a matter of days instead of months. So what this physically looks like in practice is just a single tube of cellgorithmic DNA is used to drive the state changes required for the stem cell going to the tissue-specific cell type. So this is the actual example of our control method for differentiating pancreatic into pancreatic beta cells. So you can see it's dozens of inputs. And again, we reduce this down to just one input to drive the changes. So we have shown that we can take a stem cell, program it down all three germ layers. We can make cells of the eye, cells of the muscle system, of cartilage, of the hematopoietic system. And what we're focused on today is the pancreatic system. Quantitatively, what this looks like is our process takes about 1 to 2 weeks on average for every lineage that we have tried this on. Again, we are reducing down to this number from many months long process for some cell types. And we streamline this down to just one media or two media formulations required. What this ultimately leads to is up to a 20-fold reduction in costs for some of the most difficult lineages. So 2026 is going to be an exciting year for us. We just recently received a grant from the Breakthrough Type 1 Diabetes Foundation to fund our pancreatic beta cell work into diabetic animal studies. And we have just filed some IP on our 4th generation cellgorithm system that is capable of sequential repression and activation. Up to 10 different programs can be encoded in a single cellgorithm. And one of the most important things that we're working on is a ecosystem of partnerships. So rather than making therapeutics ourselves, we are embedding ourselves into the ecosystem to work with the clinical transplant expertise, the clinical scale manufacturing partners, as well as the inputs who make GMP DNA and different types of media formulations. So keep your eyes peeled for some announcements that we'll be making in the coming months with some investment and partnerships with some of these large organizations. On the financing front, we have just closed our Series A in Q4 of last year. We were excited for this to be led by Astellas and Illumina Ventures, and very excited to have Long Game participating in this alongside Draper Associates in one of the final closings. So thank you all for your support. And what we're working on now is a top off of this Series A that will be closing in the coming months. So interested in talking to folks for that as well. Thank you for your attention, and looking forward to meeting some of you sometime soon.
Fantastic. Yeah, I think we haven't got Ryan here for Q&A, but yeah, Sebastian, maybe you want to go ahead anyway.
Sure. Yeah, I'll just sing their praises a little bit here. So obviously, Ryan and team are kick-ass founders. They have a very prestigious cap table. Astellas, the #1 regenerative medicine pharma Japanese company, is a partner, an investor. Illumina, the largest genome sequencing company in the world. DCVC, Civilization Ventures Portal, etc. And I don't know if they're announcing this yet, but they have a collaboration with, shall we say, the #1 hospital in the world, hospital brand in the world. You might guess who that is, and an investment from them. And so, one interesting fact about them is that with Astellas, they were working on a project that took several months, 6 months to make this cell type. And Syntax was able to get it down to just a couple weeks, which is unheard of. So, we like this technology because it is a broad enabling technology for every single type of cell therapy. And we would love for some of our portfolio companies to collaborate with each other, ImmuneBridge and Syntax and a handful of others. And I think there's synergy there. So anyway, yeah, we're happy to connect you with the team if anyone wants to chat.
And I think it's people will notice there are a lot of companies in our portfolio related to the stem cell supply chain and manufacturing process. How do we make these cells scalable and usable in the clinic? And Syntax fits that really well, but also then fits very nicely in terms of generating revenues early through partnerships and licensing, rather than kind of having that sort of binary option of developing specific therapeutics and cell types themselves. So anyway, on that note, we'll go on to our next presentation, also related to the cell therapy space, with Ohad from Renewable